rectangular footing. In this video, you will learn to draw a rectangular footing in the SAFE software, and assign the properties to the model. You have already been explained the problem statement, and the initial calculations. Now you will proceed with the design in the software. Open the SAFE software. Go to File, and select New Model. Change the design code to IS 456-2000, and the units to metric units. Under Minimum Cover for Slabs, change the cover both at top and bottom, to 50 mm. As explained before, the standard clear cover for foundations is 50 mm. The given preferred bar size is 20 mm, so change it to 20. Click on OK. Then select the Combined Footing Template option. The Combined Footing template in SAFE automatically implies a rectangular combined footing. The left, right, top, and bottom edge distance, as explained in the previous video, is 1 meter each. So enter the values accordingly. The spacing is along the X direction, so under Spacing option, make sure X direction option is selected. Enter the spacing value of 2 meters. The size of the square column is 500 mm by 500 mm. So enter the load size value as 500. The dead and live loads in each column is 500 kilonewtons and 250 kilonewtons respectively. Assume a footing thickness of 500 mm. The subgrade modulus, as calculated, is 2 × 10⁴ kilonewton per meter cube. So enter the value at 2e + 4, and click on OK. The rectangular footing, of the given properties and dimensions, has been generated in the software window. Use the Pan and Zoom option to reposition the footing for a better view. Now you will define the materials for defining the slab and column elements, which are M30 concrete and HYSD 415 rebar. Go to Define, and click on Materials. Click on Add New Material. Change the material name, and the material type. Then enter the values as shown, which are same as in the earlier videos. Click on OK, and the M30 concrete is defined. Similarly, add the HYSD 415 rebar, as illustrated. Once the materials are defined, you will define the structural elements with these materials. Go to Define, and click on Slab Properties. The footing and stiff is listed by default, for the footing slab and the column respectively. This is because you had used the template, and not drawn yourself. Click on the footing, and click on Modify/Show Property. Change the material to M30, and click on OK. Similarly select Stiff, and change the material to M30, and click on OK. Once done, click on OK to exit the Slab Properties dialog box. You will now define the loadings. Go to Define, and click on Load Patterns. The dead and live load are already listed, so click on OK. Go to Define, and this time click on Load Cases. Both dead and live load are assigned the linear static case, so click on OK. Now go to the Load Combinations option, under Define menu. Click on Add New Combo. For Combination 1, change the scale factors of both dead and live load to 1.5. Mark the Strength Ultimate option, then click on OK. Again click on Add New Combo, to add the Combination 2 for the service load. Make the scale factors of both dead and live loads to 1. Under Design Selection, mark the Service Normal, Service Initial, and Service Long Time option, and click on OK. The two load combinations are added. Click on OK, to exit the load combinations. You have defined the element properties, but you have to now assign these properties accordingly. First select the area over the footing, to select the footing only. Do not select the area over the column. Verify the selection in the bottom left corner. Alternatively, you can select the footing or stiff from the Select menu also, as illustrated in the Do video of isolated footings. Then in the Assign menu, choose Slab Data, and click on Properties. Select the Footing option, and click on OK. The footing property with the M30 concrete has been assigned to the selected slab. Along with the footing, the stiff property has also been assigned to the columns. This is because the software has automatically drawn the columns above the footing, and understands that, if the bottom portion is the footing, the elements on top of it has to be the stiff. Right-click on the area of the column. Make sure you are not right-clicking on the exact center on the column. The assigned property will be displayed, which you can verify. Click on OK to exit. Similarly, you can verify the property in the other column too. You will now assign the soil property beneath the footing. Click on the footing area again, to select it. Before assigning the soil property, first check for the defined soil property. Go to Define, and click on Soil Subgrade Properties. Already a soil property, Soil 1 is listed. Select it, and click on Modify/Show Property. The subgrade modulus is 2E+4, which is correct. Click on OK. Then click on OK again, to exit the soil properties. Now, making sure that the footing area is selected, go to Assign, Support Data, and click on Soil Properties. Select the soil property, which you had defined, and click on OK. The soil property of the required subgrade modulus has been assigned under the footing. In the next video, you will learn to draw the design strips, and run analysis and design on the model. Thanks for watching.